everyone. So AI is everywhere right now. It's in our code, it's in our pipelines, it's in our incident response. Every single process that we need to do with tooling is now basically like tooling plus AI. So even our parents are generating images and sometimes even content with AI. So it's proliferated every facet of our life. So whether it's being planned for or not, AI is actually becoming part of how our systems actually operate. Um, so before I dive into all of the things that we're going to talk about, I want to quickly introduce myself. So my name is Brittany Woods, and I'm currently the head of systems infrastructure at Man Group. So previously, I led engineering efforts at H&R Block, and I also led a team that's responsible for Lego.com. And across all of those roles, and even before that, as a cloud automation engineer, I've spent tons of time working in highly complex systems and also in environments that are going through significant transformation. In many cases, I've been directly involved in that transformation in some way or directly driving that transformation. So that's sort of why I've been paying a lot of attention to what we're all hearing right now in this AI space. So if you've been anywhere near engineering or engineering conversations in the last year, maybe even longer than that, but really in the last year, um, you've been hearing this a lot. AI is going to fix this. This is undefined. This can be anything. Insert whatever here. So AI is going to make us faster. It's going to remove toil. Maybe AI is, if you're extra ambitious, going to run parts of our system for us. I know we're seeing tooling that does that now. And to be fair to those processes and those tools, some of that is already happening in some places, and some organizations can already support that. So I don't want to make the blanket statement that that isn't a thing because it could be and is. But what I want to talk to you about today is what actually happens when this mentality intersects with like real systems, especially in large organizations, because that's sort of where I sit. Um, so the reality is most teams don't have a productivity problem. Like we all know that we're working in these teams day in, day out. And that productivity problem is not because teams are slow at writing code. That's really never been the thing. In fact, I don't know if I've ever worked with a team that was slow at writing code. I've worked with teams that have had to learn new things, absolutely, and new ways to do things, and ways to automate, new ways to automate. Um, but it wasn't that those teams were slow at writing code. They were learning. So I would argue then that we have productivity problems because systems are hard to understand at their core. Not only are they hard to understand, but they're hard to actually keep alive and becoming harder, really. Pipelines are also fragile. You make a small change and something breaks three steps later. And it's not because your change was wrong, your change was the right thing, but something somewhere else was already unstable and you didn't know that. Um, so deployments also require context that many times you don't have. And a lot of decisions in these systems could have been made years ago, and the context behind them is lost somewhere to time. The people that made those decisions maybe danced off into the sunset, off to pastures anew. And the documentation has been lost, and that system has evolved in ways that maybe they didn't predict, but certainly that aren't immediately obvious to the problem that you're going to inevitably hit. So, what you end up with is a system where there are landmines everywhere. Things look completely safe to do, but they're definitely not. There are dependencies you didn't know about and behaviors that are going to rear their ugly head only when the conditions are just perfect. So underneath all of that complexity, there's more. So some parts of that system might not have been maintained um, to the standard that they should have been. This happens, we get it, and it's not because nobody cared. but it's probably because priorities shifted at some point, and over time, those little shifts and those little complexities accumulate. So when we talk about productivity or speed or improving delivery, this is sort of the reality that we're all starting from in the space that we're in. The problems are already there, and now AI is sort of being positioned as the solution to the problems. So there's this belief that you can smooth over this complexity, and that AI can help fill in the gaps and make all of the things easier. What actually happens though is different. So now you just have AI operating inside of these systems, and it probably doesn't fully understand them either. It is very confidently suggesting changes and making config updates and all manner of things that seem reasonable to the engineers reviewing. But they're missing all of the things that the engineers were missing. AI doesn't change that there's something missing. It's missing that context that the engineers were missing. Those fragile pipelines that you had and those systems that are strung together are still there. And so AI is then a force multiplier, and it will take whatever the environment is that you're operating in and accelerate it to the moon, which is great if your systems are clear and consistent. You will absolutely get faster outcomes out of that. But when your systems match the reality I've just described, and let's face it, many of us feel this in our souls, you get problems faster. AI will immediately expose things engineers have been spending years working around, whether they've been consciously working around them or that that's the process that they were taught. And so it's been an unconscious thing. So if you think about deploying a service at your organization, I think an example is maybe good here. Um, think about deploying a service at your org. Now think about asking AI to do it. So it's going to need to find the repo, sure. Maybe you've helpfully set some context. So that's hurdle one done. It needs to understand the pipeline, and it needs to configure the infrastructure. That's where the complexity is at. That's almost always where the complexity is at. So you maybe, I don't know, maybe you have 5 different pipeline patterns or ways of deploying an application, depending on what it is. And then there's some missing documentation that outlines the end to end process for one of those 5 different pipeline patterns. And then you have different repos for different groups with different complexity and different rules assigned to each of those repos. And then you have separate processes for setting up the systems that the deployment depends on. So there's also some manual steps, maybe. I'm just assuming, but there might be some manual steps where somebody sort of holds its hand, holds the deployment's hand to make sure that it goes through. And somebody forgot to write that down as well. Somebody's just been doing it. They've been doing it helpfully, and things have just worked. So this isn't an AI problem. This is your platform as it's been created. Oh, my slide's not switching. There we go. So we've seen this pattern before. This isn't a new thing. So I have here what is old is new again. And as a tiny aside, but importantly, I think to this discussion, my background in platform engineering started with DevOps. It started with cloud automation engineering, doing a lot of DevOpsing, config management, all of that. And remembering when DevOps started like properly gaining traction in organizations, it didn't create new problems. I mean, okay, fine. Maybe it did at like a cultural level that required correction, but really what it did was making existing problems more visible. So suddenly, teams were expected to build and run their own systems, which exposed things in organizations like silos, unclear ownership, and how fragmented our tooling and processes really were. And it forced us to confront how work actually flowed through an organization. So it wasn't how we thought it worked. We had to truly look at how it really worked. And so platform engineering then came as a response to that problem in organizations. So the idea was to create consistency for things like golden paths and standardized pipelines and self-service capabilities. And that's all the things that we're working on right now. And so teams didn't have to then reinvent everything each time they wanted to build something new, or rely on having all of the knowledge around all of the things, around all of the stuff in your org that your operations teams typically handled. Your operations teams now codified their brain, built a platform, and those very complex systems were intended to be distilled down. And so in some places that has worked super well. But in a lot of organizations, the underlying problems are still being solved. Like we're still building out the platforms to support the organization because we just recently made this pivot. DevOps, it took us a lot of years to figure out that you needed platform engineering to support. So we're still early in that journey in a lot of places. Um, so we've reduced some friction and we've made some gains, but we haven't actually gotten rid of all that inconsistency and unpicked all that complexity in our environments. And so now AI is the layer on top of that cake. So instead of just exposing how the teams work, it's exposing how our systems are designed. And it's interacting directly with our platforms and putting pressure on all of those assumptions that we've built into them. And if you don't have your platform finished yet, that is the thing we need to focus on. So there are things that we can do that are to our advantage, really, in this situation. So it's not all bleak. We can use our understanding from AI to make the platform stronger. So where our weak spots have been exposed and our complexity sort of laid out, we can learn from this like we always do, like we learned from DevOps years ago. So a useful way to learn from this is to think of AI as not just a thing, but to think of it as a user of your platform. So almost think of it as a bulldozer of a user. So it's very fast, it's very literal, it's new to your org, and it has no understanding whatsoever of context, but it is eager, and it does all of that at scale. And so if AI can't deploy a service without extra prompting, why is that? If it can't find the information that it needs, where is it? Does that information actually exist? And so now where I'm going to insert a little bit of caution is don't just codify the workarounds into your context files. That's not what you want to do either. Take this as an action. Take this as a time to make the thing better. So fix that gap in your platform that is keeping you from deploying the service and put in what is missing. So I made this point last week actually to a colleague. We were talking about just the industry in general. And we were talking about feedback loops and how making them smaller has always been the point. He was doing some work on a new platform and was sort of talking about how his feedback loops are super short and how fast he's been able to get things done and iterate through the problem. And that is where the gains are. That is like reducing the feedback loop. That is what you want. And so through these efforts, you're building an incredibly practical feedback loop on your systems. And effectively, you can try something by doing this. You can try something, see where it fails, fix the problem, but only very quickly because you're iterating through this very fast. And so, equal to seeing AI as a user of the platform, I also wanted to take a minute to talk a bit about how we have to sort of see everyone now as users to our platform. And when I say everyone, I mean effectively everyone in your organization. So AI is lowering this barrier to essentially producing code, and therefore more people can contribute to our engineering spaces than ever before. So that's very, very powerful. And orgs that can harness that, it's even more powerful. But it's also it's changing the shape of what your organization needs from your platform. It changes the shape of what supporting these infinitely complex systems look like, and it also changes the shape again of the platforms beneath it. So SREs are also going to feel this. They're going to feel that changing shape. Um, they see more of the incidents because more things are going straight to production and skipping lower environments. Deployment processes aren't being followed because the AI didn't know, and nobody really knew to check. Because again, everyone is producing engineering outcomes at this stage. And so debugging things becomes even harder because not only do you not have the context, or your SREs don't have the context, but the people that are building it might not have had the context either. And so we've all heard about AI chunking out thousands of lines of code as well. And so that also makes debugging harder because you have quite a bit more to go through in terms of like changes. So what's happening isn't just that AI made things faster, it's that more change is hitting systems with less understanding and fewer guardrails. And this is exactly why having a strong platform is more important now than it's really ever been. So when more people and more AI essentially can produce changes that we once relied on just a small set of individuals for, um, then really what we relied on a small amount of automation for, ultimately we need to rely on the platforms for. Um, it is effectively your platform that will determine whether those changes are safe or not, and whether or not they're understandable to others as well. So when I say a strong platform, I also wanted to put an aside here that I don't necessarily mean more tools. More tools can mean more complexity, not always, but just throwing tools at the problem never solved it for us before. So it's definitely not going to solve it for us now. Because more complexity means less predictability. And again, it's harder to feed AI the appropriate context. Um, so again, the point I'm making here is not that we should not use tools, and I'm also not saying that we should make things harder again because that's not what we want to do either. What I do mean is a platform that doesn't rely on people remembering what to do. That platform should shape what they can do, and that platform should make the right thing to do, the easy thing to do, for all of your systems, and then more importantly, make the wrong thing to do hard. Like make it so people don't have to stumble onto the wrong thing to do. It's just not possible to do, or it's really complicated to do. So, what are the ways that you can make this a reality, which effectively enables some safe AI in your systems and doesn't make your SREs run for the hills? So, the first is don't forget about guardrails. As I said, processes can't rely on people remembering them. Especially when you have more people contributing and your AI is generating its own changes on top of that. If something shouldn't go to production, the system should prevent it instead of relying on a hidden document that might outline a constraint somewhere that your AI has to find and source. So instead of saying to users, please follow this process, build your systems where the process is enforced by default. And then you can also focus on consistency. So if every service deploys different AI, it's going to amplify inconsistency. Um, so I said that backwards actually. If every system or every service deploys differently, it's the AI. There we go. That is going to amplify that inconsistency. If you remember my deployment example from earlier, you have maybe 5 different or slightly different pipelines doing all roughly the same thing. Instead of that, reduce variation where you can. So there should be a clear and consistent path that most services follow. I mentioned golden paths earlier as being like a key piece of platform engineering. Um, and they're so important to stable environments that are built on strong platforms. You need to have and define those golden paths. Um, and then I've reiterated it's not about taking away abilities to innovate for teams. That's never what we want to do. It's about making our systems understandable, and enabling innovation while we make them understandable. And then ownership is my last point, and maybe it's the most important, because I think it needs to be explicit. So if something breaks, it needs to be immediately obvious who owns it. So it shouldn't be buried in a Slack thread somewhere for somebody to find. When AI is involved, it becomes very easy to lose that clarity of who owns what, especially if it's in that buried Slack thread somewhere, or it relies on somebody who's been around for a lot of years to know who owns that thing. Um, Also, if AI generates the change for you and an engineer then reviews it, and then there's a pipeline that somebody else owns to deploy it, who actually owns that outcome? Those are the questions that you need to ask. Who owns the outcome from all of that? And if the ownership isn't clear when you ask yourself that question, the system itself slows down, or things don't get fixed, or again, if it's not immediately clear to you, it's definitely not immediately clear to any agents that you have running or deploying. And all of these things come back to the same thing, really. And it's that we're not just building platforms that let people or AI do things. We're building them to shape behavior and guide how the work happens, regardless of whether it's happening by a human or a system. And then when we do this, we make those safe and consistent outcomes the default. And then our organizations, and let's be real, our mental health as well, benefit in the process. So if we don't do these things, then SREs, like I said, are going to feel the fallout. So AI also goes from maybe amplifying the outcome to actually doing so. And it's all driven by having that solid platform. So thank you so much. Follow those steps and build solid platforms for your AI to run from. Thank you.